Today I'd like to introduce Tom Colclough, a former health professional who has previously worked in the NHS of UK and public health facilities throughout Africa and the Middle East. On today's show, we're discussing water. We appear to be running out of fresh agricultural water in America. How can farming improve efficiency and preserve such a valuable natural resource? Tom has been involved in health-related projects of development, globally working in many countries of Africa, the Middle East, and Asia. He has a particular interest in water conservation and the development of sustainable agricultural and horticultural practices for food production. His most recent projects include the promotion of biodomes, providing food and employment resources in refugee camps of the Middle East and Africa, where access to water is limited. The company he works for provides vertical growing systems in closed environment growing biodomes, providing food with reduced water requirements. Tom, thanks for joining us on the program today.
Very nice to be here talking to you.
Tom, what's the current water situation in America?
Well, if we consider some of the issues with regard to the availability of water and where that availability is, we can see a drastic reduction in the amount of water available. And this is due to various reasons. One is the consumption is actually increasing at such a rate, but also the amount of, or the percentage of that water that has been taken up by agriculture, which is over 70%. 70% of that reservoir water will be used on field crops, say field crops that we'll use for irrigation and fertilization. But the percentage is increasing with regards to the utilization for various reasons. Now, it depends where you are in the United States, but certainly the sensitivity to water conservation, particularly say in California and parts of Arizona, is an issue that is now almost to the point of being critical.
Mm-hmm.
And the criticality of that is because it's a drought area. You know, they've had 6 years without any substantial reservoir topping up. And also the reduction of those reservoirs. Even the reservoirs have to be fed by somewhere area, and this drought has had a significant impact. When I say a significant impact, it has obviously increased the price of producing produce in California. So the net effect of that is that you're paying more for your vegetables because of the shortage of water.
So what you're saying, I guess, is they are inefficient in their process. All you have to do is look at the way fields are currently being watered, with big sprinklers spraying vast amounts of water on crops. I imagine a lot of that water is being evaporated in the process.
Absolutely. You know, it's quite difficult to actually measure the evaporation rate of actually what goes to that specific plant. But you can imagine that it must be 90–95% evaporation in some areas, particularly where you have high atmospheric temperatures. So that the sprinkler system is highly inefficient. And then when it hits the ground, well, again, you've got evaporation rates and runoff rates. So it's highly inefficient. So we've got to have a look. We've got to have a look at methods that actually increase the efficiency. What are those methods of increasing the efficiency? Well, obviously, to actually directly feed or make sure that the irrigation goes directly to that crop in the field. And that could be in a field crop, for example. You know, there are methods of having feeder lines and smaller lines that are able to actually feed individual plants. But that's a very expensive method to do that on a two-dimensional plane. So we are looking at ways of actually bringing in the vegetable production into a facility and making a three-dimension so that you can actually not just use the water once, but recycle the water, but also make sure that that water goes directly to the plant and what you're trying to grow. To make it more efficient, all we're trying to do is increase the efficiency model at the moment and examine where the water is actually going in agricultural areas.
So what you're telling me is that the water you are using for the plant, the only water that leaves the production facility, is the water that is in the leaves or the product itself, and none of it's wasted to the air or sewage?
Absolutely, absolutely. That's absolutely correct. What you're trying to do is conserve the water and make sure that the water that you're actually utilizing goes directly in to increase the biomass and increase the productivity of that. And it's for the benefit of the farmers because, you know, they obviously use pumps and hydrocarbons fuel to actually pump this water around, make it more and more efficient and increase the overall efficiency of the used water.
So everyone is concerned about safety of their food source. What are some of the issues? Whenever science tinkers around with nature, there's always the concern of contaminants or something being introduced to improve efficiency or what have you. Maybe explain to our audience a bit more about the food security with this kind of new technology compared with what's currently being used.
Surely. One of the things that you're making the assumption is that water that is used in agriculture is safe. And when I mean safe, I mean like that it's possible that you wouldn't mind drinking it yourself, but it is also free from contaminants, whether they be heavy metals or whatever. And I say whatever because it can be whatever. I mean, like you've only got to look at the movie Erin Brockovich, where the quality of a water has an impact. But, you know, people had to take up their own mandates to examine what was the safety issues around that for themselves and their children. So if we look at, say, initially the water to actually go to agriculture, is it clean, is it safe? Then your question actually, what is actually being put into the water in the food production, whether it be fertilizations, and you know, like everybody fertilizes, but you know the problem is where you have a concentration or a mismanagement of pesticides in the area. Everybody knows that, you know, methyl bromide is actually used in soil sterilization, but it's a very liberal use. And the problem is that the soil itself can actually contain concentrations that are released then by further irrigation, and not necessarily to the percentages that are necessarily safe. And obviously depends on what crops are being used, because you know you have to be pretty selective of what you use on what crops, because if you're putting chemicals on foliates that you're not going to be eating the leaves, for example, you're going to be actually eating the tuber or whatever, then it has a different impact. But if you're looking at field crops where the whole of the plant is going to be consumed except for the roots, then you need to look very carefully of what you're actually putting on that plant. And also its judicious use. What regulation is in place in that specific area so that it can be monitored prior to its consumption. But I'm afraid, you know, that there is legislation, I'm sure, regional legislation, but some areas of the world, there's no legislation, there's no guides, there's no ability to have checks and balances in place that will enable this food security. When I say food security, I mean, is it safe to eat, but is it safe for consumption full stop, whether it be for animals as well?
Well, obviously we're buying so much food from international sources. I mean, it's coming from South America, it's coming from Asia, and obviously we have no governmental control over them other than analyzing the product that comes in across the border. What about food taste? How's the difference between, I mean, everyone is concerned about the strawberries now compared to the strawberries when they grew up. Tell us a little bit more about flavor.
Well, obviously, flavor is important, and I think you know, as you've indicated, you know, the fruits that you had as a child. But I think what you're actually remembering is the fact that that fruit was probably grown locally, and it was allowed to mature. Now, this system that I'm advocating allows that facility to take place again, because market gardening is too international at the moment. It's using far too much hydrocarbons to actually be planted whatever, but also flown in. The logistics chain is high. And also, as you've indicated, the regulation wherever this food produce is actually coming from is not necessarily under the control of the individual. So with regards to taste, it really is important that people actually are aware that if you actually grow this produce closer to home, closer to where it's consumed, it will taste better, without shadow of a doubt, because it will arrive at the right level of maturity with the right sugar levels. As soon as you pick a strawberry, it doesn't increase, or has the ability to actually increase its sugar content. So it doesn't taste the same. But if you grow a strawberry and you pick it directly off the plant itself, it's not a noticeable distance. It's a tremendous difference of what you would actually experience.
From what you're telling me is this new technology can be implanted in various climates, then it's not specific to hot weather climates or ideal climates. Is this like a greenhouse?
Yes, it's like a greenhouse. There's not much difference than a greenhouse other than that it's a positive pressure greenhouse. A positive pressure means that you actually can control the environment quite considerably different than that of a greenhouse. The problem is great inefficiencies in greenhouses. And effectively, what is a greenhouse there to do? Well, it's there to actually protect it from the elements, the plants that you're actually growing. And also to reduce the evaporation levels because of the solar gain that you may have. But the work that we've been doing with regards to research and development in our closed environments has actually demonstrated that you can actually control very significantly the environment for those plants. Not only are they getting the optimum levels of water and nutrients, they're actually being controlled. So daily you can actually see the reaction of the plant. You can measure the biomass that is actually being grown, but you can also check the health. So if you reduce the risks, and this is the problem with regards to farming in general, is that the farmer is actually taking the risk until that produce is actually in market. So he's taking the risk of whether it'll grow, whether it'll produce whatever. And if you can de-risk it for the farmer, then you can actually de-risk it for the farmer who's taking a loan out, so that he has a percentage confidence that he will actually get the return on investment that he's actually made. So it then is not a gamble for the farmer. He has more greater percentage of confidence that he will make his payments, but also make a margin on it. But also, if we actually make that local, then the people themselves can have a say, and they usually say by actually buying his produce. So we've also not got to look at what the farmer's risk is. We've also got to look at how produce is actually purchased. And already people have actually made the movement, made a movement with buying local produce within 100 kilometers where they live and where it will be consumed. And that's important because then the visibility, not just the visibility of the farmer, but the visibility of the produce that can be produced will make its own mark, will make its own market.
This sounds very interesting, and obviously there's more information on a website. How can people look for more information about what your projects are and what you're proposing?
Well, if they do a Google on Ecotech Energy, which is available, what we do is we do high-level presentations, but also give a very, very comprehensive perspective of what we're trying to do, not just in the USA, but globally. Because, as we know, our food comes from around the globe. So it's important that we actually take this technology around the globe and into areas where localization of food and food production is important. And also that we have an impact in those areas where there is water problems with regards to contamination, availability, and regulation of it as well. So that we can overall increase the efficiency of our food production.
Tom, thank you very much for joining us on the program today. It's been great having you.
Thank you very much. It's been a pleasure.
Tom Colclough was our guest today. If you would like to learn more about water conservation and the current management of this diminishing resource in a global agricultural and horticultural context, visit Ecotech Asia to find out more information and presentations on the topic. Thank you all for watching. I'm Lisa Nix. Have a great day.